Okay, so let's just start with the product rule. And I'm going to make it pretty much just a straightforward product rule problem. Okay, and if we'll remember, it's first derivative of the second. Okay, and those are multiplied plus the second derivative of the first. Now, some books will actually go derivative of the first times the second plus the um, second derivative of the first. It doesn't matter because plus is in there, but I just learned it first derivatives of the second plus the second derivative of the first. Okay, so that's the way I always say it. So that means f prime of x is going to equal, well, first is sine x, so I just write it down, times the derivative of the second. Well, the derivative of cosine is negative sine x. Okay, plus says the second, which is cosine x, derivative of the first, the derivative of sine x is cosine x. Okay, so that means that f prime of x is equaling the negative sine squared x plus cosine squared x. Okay, and that's just a plain old simple product rule there. The chain rule, on the chain rule, and I'm not going to give you some f prime, g prime. It is about like f of g of x because they're nested functions. And for the most part, what we do is we start with the outside, take the derivative of the outside times the derivative of the inside, and you just keep working. Okay, so if I had something, I'm going to give you a pretty easy one here. Let's say f of x equals 5 times 3x squared plus 4 all to the second power. Okay, now you could square out 3x to the fourth plus 4, but we're not going to do that because it's a lot easier just to use the chain rule. So what's on the outside? It's like we have 5 times this chunk here, right? So if this were like 5x squared, what would we do? We would say 2 times that 5, and then we would take 1 away, right, from the 2. So this gives me 10 times my chunk, my blue chunk. I don't do anything to it right now because that's the inside. It's like if we used to call it the peanut M&M rule, and if you had to eat a peanut M&M and you couldn't just bite into it, like you had to eat down to the center, well, the first part you would take care of is the outside chocolate colored part. Okay, and then you would take care of the chocolate part that doesn't have the colored shell. So you take care of the shell first, you'll eat it off, yum, 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 a little bit, and then we would eat the chocolate part, and then the inside would do the peanut, so the outside. So the outside of the shell right there, I said 2 times the 5 is 10. I've now left the chocolate part, okay, 3x to the fourth plus 4. Of course, that's to the first power. If it were to the third, it would be down to the second. Now I want to say times has time to eat the chocolate part or the peanut part, whichever part we're to. Let's take the derivative of the blue part there, the inside. Because see here, my blue part's still the same. And that's going to be 12x cubed. Well, the derivative of 4 is 0. Okay? Now, all that's multiplied, so I can actually say 10 times the 12x cubed, which gives me 120 x cubed, all times 3x to the fourth plus 4. Okay? You can multiply that out or not multiply that out. Generally, we don't. And then sometimes we have a combo. Okay, so let's look at a combo here. They'll do something like f of x equals, why don't we do, let's we'll say 5, but this time we've got 3x squared sine of 2x. So we got all kinds of things going on here. All to the, we'll just say let's say the third power this time. Okay, so what we're going to do first is what's that outermost part? So we're looking at the chain here to start with, the chain rule. Okay. So I'm going to say f prime of x is going to equal 15, and then my blue chunk, right? 3x squared sine of 2x. All of that squared. All right. Now I'm ready to move on to the inside part. I've got to take the derivative of 3x squared sine 2x. That's all I'm looking at is the blue part. So times, okay, now that's a product rule. Here's the first, here's the second, and that second actually has what in it? It actually has another chain in it. Okay, so the first 3x squared, derivative of the second, well, what's the derivative of sine 2x? That outside is cosine 2x, right? And then the derivative of the inside of sine of 2x, so the derivative of 2x, which is 2. Now this 2 right here that I just wrote down doesn't go inside the cosine. We're going to bring it out to the front in a minute. Plus, okay, the second, which is sine 2x, okay, derivative of the first, which is going to wind up being 6x. Because what's the derivative of 3x squared? 6x. Okay, let's see if I can write this a little neater. So that's f prime of x equals, this little part right here is just fine. That's 15, 3x squared, sine 2x, all of that squared, times this whole chunk right here. Let's see what that is. Now, I told you this 2 right here doesn't go with that cosine 2. It can go up to the front. It's like saying 3x squared times 2x times 2. So that's really just 6x squared times cosine 2x. Plus, well, just like with that 2 that has the arrow over it, this 6x is really saying sine 2x times 6x. So plus 6x sine 2x. Okay, now we could go ahead and distribute all that out, but we're not going to. That's a little much. You can leave it just like that. So maybe that clarifies what the product rule is, what the chain rule is, and then most of the time, since you're in Cal 3, you will see some combination where it's all, you're using them all at the same time.